Hey, howdy, friends. It's Steve DePoe here with the Rose Realty team with this week's real estate vlog for North Texas. Hey, you know what? Last week I told you we were going to do the Rose Realty team listing process, but when I started to get into it, there's a lot of moving pieces to it and a lot of parts, and it would probably have been like a 10 or 15-minute video. So we decided to like hold off on that, maybe chop it up into smaller pieces and present it that way. But today we're going to talk about robotic built homes. Actually, when I started to get into this, do the research on it, found it like really, really interesting. So for those of you that are about my age, you remember the Sherman and Mr. Peabody show, and we're going to take you back to the way back machine just for a couple of minutes. So when I was a new product design manager at a New Jersey-based medical technology company, we dabbled in something that was called stereolithography, SLA for short. And what these SLA materials did was, SLA process did rather, is we produced non-functional replicas of products or new design products that we were working on, so that we can take them to clients and potential clients and maybe people that we were kind of working with as partners in a way, and say, hey, what do you think of this, and how do you like the look and feel of it, and that kind of thing, right? And that way they got an idea of what we were working on and whether they wanted a flange a little bit bigger or button a little bit smaller or whatever. And you see in a picture here, these are kind of like the things that we created, something, something about this size. The downside to it is totally non-functional. Okay. If you had a joint and you actually move that joint and move that hinge, you would snap the materials and you would break it and it would become useless. Now, it wasn't very useful to begin with. They said it was all kind of look and feel. Well, today, we get the materials. The materials technology has progressed a lot in the last 30 years. And so we're at the place that we are now, where they're making, heart valves out of this, what today they call 3D printing. Heart valves or hip joints and that kind of thing. And you might have guessed it, homes. So we're going to touch on that in just a second. Before we go any further, hey, we'd like you to go to our YouTube channel. That's youtube.com/@moving-to-Dallas. That'll get you to our YouTube channel, and you'll be able to like and subscribe to that channel. And then you'll have access for free, obviously, to all of our videos that we've ever done. I mean, there's something like 400 of them now. And you'll be able to kind of take a look at them and look back and say, hey, I think a year ago they talked about, X, Y, and Z, like kitchens or something like that. And you'll be able to go back and take a look at those. So, hey, we thank you for doing that, and we really appreciate you for supporting us and supporting our channel. So, hey, let's get back into this stereolithography or robot built homes. So back in 2018, this company called Icon was formed, and they were formed to address the global housing crisis as something that needed radical changes that they thought. And they wanted to do a construction scale 3D printing is designed not only to deliver high-end homes, but to do it affordably and quickly. Now, when they create these homes, they call that printing. Actually, applying the materials, they call that printing. Okay, that's the technology. That's the term that they use. And obviously it's 3D, so it's called 3D printing. Back a couple of years ago, surprisingly enough, this Icon company got a $65 million grant from NASA. Now, let's go. How do you connect the two, right? Well, NASA said, once we have a mission to Mars, which we know that Elon Musk is working on, once we get a mission to Mars, how are we going to go up there and build, housing and labs and storage, et cetera, for the people that go to Mars, okay? and how are we going to do this quickly and effectively, maybe even before the people, the Mars astronauts get up there, right? And so they gave this grant to Icon, and Icon said, "Oh, let us take a shot at it," and that can kind of also then spread out their ability to do these what they call robotic homes, or 3D printed homes. So they created this printer they called Vulcan, and this Vulcan printer can print walls, or construct walls, let's call that, 10.5 feet tall and covering a surface area of around 3,800 square feet, right? So that means that they can create, or they can build or print a house that's about 2,000 square feet in about a week. Now this can operate, this machine, this Vulcan, with the help of one or two, not many, one or two or three, let's call them construction workers or printers, around the clock, 24/7, and create like a 2,000 square foot home in a week. Now the concrete is mixed, okay, and fed into the Vulcan automated feeder, and they call this the concrete they call magma. And the software then guides it through the process of building the walls, interior and exterior, and then it kind of follows a floor plan. Okay, so there's probably, based upon my experience with the stereolithography a bunch of years ago, the complicated part of this is probably coming up with the design is probably sort of easy, but then the software that would slice, and we called it slice and dice the model, into really thin layers that then were able to be spread or created with the in this case the Vulcan machine. Now, if you take a look at this picture we've got here, you can see that's the nozzle that they're using to spread the cement or the magma in a wall like in a layered kind of wall like construction or finish. Kind of really neat. What's the cost of this? Well, they feel that they feel, the Icon people feel that it's sort of expensive right now. We'll get to the real cost in a second, but they feel that it's sort of expensive right now. But as they do more and more of these, and they start driving the costs down, and maybe they get some competition, who knows, that they can bring down with the costs of what they call in the traditional wall systems, right, into to much more affordable. So now they developed another machine called a Phoenix, right, able to do bigger walls and make them into multi-story walls up to 27 feet high. 27 feet high, you got to think, is probably a 2-story building. Okay. And the nozzle, again, there's the same basic kind of system, except it's much bigger. It's able to float up and down to greater heights to get that 27-foot high wall. I want to draw your attention to the right side of this picture. You see where there's layers. They look like round bands, right? Well, that's where the printing takes place, right? And they squeeze you. Think of it as a tube of toothpaste, or even caulk in a way, right? That when you squeeze it out, it comes out in a line, or like a kind of like a tube or a ribbon in a way, right? And it's just one layer on top of another on top of another. And that's what your inside wall is going to look like. So when I was kind of looking at these pictures, I thought, well, that was kind of neat to have this kind of textured inside wall. But I also thought, well, would you kind of get bored of it, after a while? I don't know. Right now they're saying that they can do the wall system at around $25 a square foot. But then if you wanted to add the foundation, and the roofing system to it, that would come to around $80 per square foot. I kind of have a little question about the roofing system because this stuff initially is going to be soft and not dried. Okay, so I'm not sure how you would necessarily support a roof with nothing underneath it. Okay, that to me would be just kind of sag in, but maybe they have an approach to support that, or maybe they construct it differently and put it in place. Hanging pictures. So we saw in the previous slide, we saw pictures hanging on the wall. So you would hang those pictures with basically a cement screw. You'd have to drill in with a cement bit and then put a cement screw in there. So the downside to that is if you decided, well, I don't like this picture over here anymore, I'm going to move it over there, then it's not as simple as getting some spackle and throwing it over and throwing some paint on it, maybe doing a little bit sanding. There's probably some texturing and that kind of stuff. And so that could get a little bit complicated if you wanted to move pictures. The other thing I'm wondering about, which they haven't talked about in the literature, is the insulation. Okay, so if you build this either in a cold climate, remember these are cement walls. Okay, so think about those of you that have lived in the Northeast, okay, or northwest of the country. Think of basements, okay, and how cold those cinder block walls are in the wintertime. Okay, so do they fill in the gaps in these walls after they're printed? Do they fill that in with insulation, maybe foam in place or that kind of stuff, or shove down fiberglass, something along those lines, or are they just a void? I don't know. That's kind of like interesting questions. Anyway, so something to look into. I've actually talked to several of these builders. It was one or two builders out there right now. I've actually had conversations with them. Forgot to ask them those questions, but their businesses are coming along. It's kind of a fad. It's kind of like an interesting fad right now. However, as we get further and further down the line, and depending on regulations in terms of forestry and that kind of stuff, it may be the way to go in the future. Also would be a big benefit in some areas like let's say like Oklahoma, where there's constantly tornadoes and hurricanes go through there, and wreak havoc on houses. So this would be a benefit to that, because this would be a concrete home. So anyway, something to think about. Hey, so we're going to keep the same line of thought. Next week, we're going to talk about barndominiums. Is the barndominium lifestyle right for you? This is Steve. I am with the Rose Realty team. So long.